Network architectures refer to how different logical elements of a network are put together to make the network function. Here, pay attention to the term logical because this is what differentiates network architectures from network topologies. Because when we are talking about network topologies, we refer to the physical structure or elements of a network. While when we're talking about network architectures, we're referring to the logical elements or the structure of the network. The layered architecture is the most fundamental architecture in networking. It lays a foundation for everything else when it comes to network architectures. The layered architecture in general enables the exchange of network messages, which is probably the most important function of networking. A layer in the layered architecture is a self-contained unit representing a functionality, whatever that layer is expected to be doing. And each layer has its own constraints. For example, a layer depends on or uses the layer below, and it cannot be, for example, using or depending on the layer above. The same layer provides services the layer above. So for the layer above, of course, because the layer above depends on the layer below, the same layer provides services the layer above. To illustrate this point, I have this diagram in the PowerPoint slide, and as you can see, the application layer now depends on the transport layer, and in turn the transport layer depends on the internet or network layer, and we'll discuss more about what each layer does in the remainder of this lesson. There's this very famous reference model for the network architecture called OSI 7 layers, and it was an idealized network architecture, and the layers in the reference model or the network architecture were never fully implemented. So for example, we had application, presentation, session, transport, network, data link, and physical layers. So simply probably too many layers. And in reality, what happened was this model got abbreviated into a more realistic 5-layer model or the architecture called hybrid TCP/IP OSI architecture. So now the modern network architecture being used today to deliver network messages is this hybrid architecture, which consists of 5 layers: application, transport, internet, data link, and physical. And we'll be looking at each of these layers in the remaining lesson. Before we get into the details of each layer and what it does, let's talk about the role of the layers in the hybrid TCP/IP OSI architecture in general. When sending a message, each layer in the network architecture is responsible for constructing a frame containing a packet, which in turn contains a message. When receiving a message, each layer is also responsible for deconstructing a frame to retrieve a packet and eventually a message out of the packet, and the message is actually consumed by the application layer. For example, the application layer is responsible for generating a message to be exchanged between the two hosts, and also responsible for retrieving a message, in this case, if you're on the receiving side, out of the packet. And the rest of the layers below the application layer are in charge of packaging the message so that it is deliverable to the other side, or if you're on the receiving side again, unpacking or unpackaging the message so that it can be consumed by the application layer. The application layer depends on the transport layer, which is right below the application layer, and the transport layer is responsible for managing port numbers. So if you're on the sending side, you're assigning the port numbers to which the message is going to be delivered. And once the message is arriving at the host assigns the message based on the port number to a particular application. And if you're on the receiving side, of course, the transport layer is responsible for interpreting the port number so that it can send the message to the right application. The transport layer is also responsible for error checking and retransmission using the mechanisms such as checksums and sequence numbers. A lot of times what happens is when the messages are arriving at the target host, the messages, they show up out of sequence, or the messages themselves somehow show up damaged. So to make sure you have a correct message, you have to be doing this error checking, and if there is an error in the message, you have to ask for the retransmission of the messages. The internet layer is responsible for assigning IP addresses to the packets and also interpreting the IP addresses of the packet if you're on the receiving side. And the internet layer is also responsible for routing packets from one network to the other. So the internet layer is really necessary for transmitting network messages in between different networks. The data link layer, which is below the internet layer, is responsible for sending frames containing packets within a single or local network or local area network. So the data link layer is really responsible for the exchanges of the messages within a single network, not in between the networks. That job is given to the internet layer. And note that we're dealing with frames containing the packets in this case, not the packets themselves. Finally, the physical layer is responsible for conversion between frames and electric signals, because at some point the frames, they have to be converted into electric signals so that it can be transmitted through the transmission medium, for example, an Ethernet cable, or if the frame is transmitted through a fiber optics cable, then of course the frames are translated into light signals instead of electric signals. And when the signal is now received by the receiving side, then the signal is, whether it is electric or light, is going to be transformed into zeros and ones and then turned back into frames.